All right, I'm Ed Wakefield, and this is Right to Know training. So this training is mandated by the state of Minnesota. It's to help you guys understand the potential hazards in the workplace. So once a year, and at the start of your employment, you have to have this training. So you will see this as long as you're here every year. So our topics today will include how are we going to identify those chemical hazards, safety data sheets in particular, how to protect yourself from chemical hazards, the specific hazards that we're going to see here at Cooperative Plating. The two most important ways of identifying chemical hazards are labels and safety data sheets. So we'll go through each of those. Specifically, we're going to show you the National Fire Protection Agency labels. We'll abbreviate that as NFPA. And then also the globally harmonized system labels, also GHS. And then we'll go through the safety data sheets. This is an NFP label. So again, NFPA, National Fire Protection Agency. So these labels are required by the fire department. So once a year, the hazardous substances chief from the fire department comes in and audits us. He's looking for things like this in addition to sprinklers and that sort of thing. So where you're going to see these labels are on bulk tanks. So you'll see them on the sides of plating tanks as well as some of the storage tanks that are on the ends of the building. They're all this 4 colors. So blue, red, yellow, and white. The blue is for health hazards. The red is for flammability hazards. How flammable is it? Yellow is for reactivity. Remember, with chemicals, reactivity means that when things mix, they're going to give off heat, energy, potentially explode, that sort of thing. So we need to know what might happen to them if they mix. And then white is for special hazards. So in the red, the blue, and the yellow, you're going to see a number. It's going to range from 0 to 4. The higher the number, the higher the hazard. So in white, you will not see a number. That will be either blank if there's no special hazards, or there will be some sort of letter codes that show up. So we'll briefly go through each of these. So health hazard codes will start up at 4. Again, the higher, the more hazardous. So at 4, very short exposure could cause death or serious residual injury. And again, residual injury means an injury that never goes away, right? You get a burn that you have to have a skin graft and that's there forever. You lose a limb, that sort of thing. It's a injury that stays around. Whereas you go down to 0, it poses no health hazard, right? No precautions are necessary, and it would offer no hazard beyond that of ordinary materials. So, for instance, regular tap water would probably be a 0 for health, right? Because you can drink it and it's not going to hurt you. So flammability codes, similar up at 4, it's going to rapidly or completely vaporize at normal pressures and temperatures, and it's readily dispersed in the air and will burn readily. So vaporize, right? If it's a liquid, it becomes a gas. Why is that important? Because when there's a fire, what's burning is the gas, right? So the liquid itself will never burn, but if it's able to vaporize, it's gonna have the ability to burn. Whereas down at 1, you got to preheat it before ignition can occur, meaning the 70 degrees or so that it's in this room, it normally wouldn't be flammable. You'd have to bring the temperature up higher than normal temperatures for it to catch on fire. So reactivity, similar. At 4, the stuff's going to explode, right? Readily capable of detonation or of explosive decomposition. So explosive decomposition, again, it's breaking down into constituent parts and it blows up at normal temperatures and pressures. So stuff like nitroglycerin, if it was sitting here at normal temperature and you give it a little bit of tap, just a little energy, you could potentially make it explode. That's what you're going to see there. Whereas at 0, it's normally stable. We could sit it on this table for days and days, months, years, and it's not going to do anything. And is not reactive with water. So I mentioned the white, the special hazard codes. So these are examples of what you're going to see there. Acid, alkali or base, corrosive. So generally you're going to see that corrosive more than you're going to see the alkaline or base, because if it's, for instance there it says corrosive, very high or very low pH. Very high pH is the same as alkali or base. Very low pH is acid. So most people just put corrosive so you know that it's corrosive. It will burn your skin, it will eat away metals, that sort of thing. OXY for oxidizer. Oxidizers are a special class of chemicals. Oxidizers make fires burn hotter and faster. So they bring oxygen into a reaction. They can take things that are flammable and without an ignition source cause them to start on fire. So oxidizers we don't like mixing with flammables, so it gets its own special code. The W with a line through it reacts with water. Obviously this is problematic because there's water everywhere, including humidity in the air, which can condense and become water. So you know we have one product in the plant that reacts with water, and that is nitric acid. And sulfuric acid, because they heat up when they mix with water. So 2 products. So luckily it's not a violent reaction for the most part, but it does heat up significantly, so one has to be somewhat careful with it. PA, you're going to see them on the bulk tanks. If you see higher numbers, those are higher risks. GHS, again, globally harmonized system. So the GHS harmonizes the way hazards are communicated by means of warning labels and safety data sheets. So this GHS label was created and it is used by multiple countries. Most countries in the world have signed on to this. So if you were to go somewhere else outside the United States, you would see the same labels. Now, again, they would be potentially in a different language than English if the English is not the major spoken language there, but the label will look exactly the same. One of the reasons that works well is that they use hazard pictograms, so pictures that tell you a little bit about that chemical. This also uses signal words and hazard statements. This is an example of a GHS label. You're going to see this on any product that we buy from our suppliers that comes in packaged to ship, right? So for those of you that aren't platers, which I think is this entire audience, you'll probably not have to deal with these most of the time. These are going to be the chemicals that are in the back room that are still in their original packaging. But you see that there's 6 numbers there. Number 1 is the product identifier. So this is the name of the chemical. I say that with air quotes because it's not always a proper chemical name. This may be a brand name. It may be a name that the supplier uses to market their product. So it may be super duper special chemical. So just keep that in mind, that it doesn't always tell you what the chemical is. Underneath the name though, you see that there's a UN number and more importantly a CAS number. The CAS number is a chemical abstract number. That is specific to the chemical. So if you get exposed to this and you need to talk to a doctor, it's always good to have that CAS number because that gets them to the chemical right away. And you can match that to an SDS. Number 2 is the signal word. There are 2 signal words. There's either danger or warning. Danger being the more severe. 3 is the hazard statement. So what about this chemistry, what about this chemical is hazardous? So in this case, it says highly flammable liquid and vapor. Okay, so that's the highest hazard is what you want to put first. So it's going to tell you a little bit about it. Number 4 is the precautionary statement. What can I do to make sure those hazards don't cause me to have a bad day, right? So how to store it, what PPE to wear, that sort of thing. Number 5, where did it come from? So it's who's the supplier, what's their address, and more importantly, what's a phone number where we can get a hold of them if there's an emergency. Number 6 are the pictograms. And here are all the pictograms that you might see on one of these GHS labels. You'll have up in the top left there an exploding bomb. Obviously that's for something that's potentially explosive, self-reactive. Again, remember chemistry reactions can be bad news because they can give off energy. The top middle is corrosion or corrosives. So these are things that again can cause skin burns, eye damage, can corrode metals. Flame over circle. Remember we talked about oxidizers a little while ago with that white color on the NFPA label? Oxidizers make fires hotter and faster. Mixed with flammables, very dangerous, right? So it's a circle with a flame over top of it. Middle left, gas cylinder. So gas is under pressure, right? It's not necessarily flammable, but if it's under pressure and that cylinder breaks, we can have a bad day. The middle, the center, middle. It's a dead tree and a dead fish. These are environmental toxins. So these are things that if they were to spill outside, potentially causes problems from an environmental standpoint. Skull and crossbones. So that says acute toxicity. Acute means right now. So this is toxic, poisonous. This is something that will kill you right now, right? It'll cause you great harm now. We'll come back to that in a second. Exclamation mark. You can see there's several things listed: irritants, skin sensitizer, acute toxicity, narcotic effects. These are all things that don't fit very well into the other categories listed. So the exclamation mark is actually used on almost every label I've seen because it kind of catches anything that doesn't fit elsewhere. Bottom middle, health hazard. So the reason that I brought this up, we talked about on the skull and crossbones. Reason I was talking about that being an acute toxic, something that hurts you now. The ones that are health hazards that have that little starfish-shaped guy on the person, these are things that will hurt you, but over a longer period of time. Things that are carcinogens, mutagens, things so they can change your DNA and cause cancer and other problems. They can cause you to have reproductive problems, respiratory problems. So they may not kill you right away, but they will cause problems for you over the long term. And then the bottom right, the flame, obviously for flammables. So any questions on those pictograms? Again, these are going to be on chemicals that are still in their original packaging from the supplier. So where we'd see them in our shop is generally the back room. Safety data sheets are provided by the chemical manufacturer to provide information including the safe use of a product. Safety data sheets, for those of you that have a computer and sit at a desk all day, they are on the network. For those of you that don't, the picture that's on the screen right now are 2 binders that actually sit in the shop that the lab keeps updated. So any new chemical that comes in gets a safety data sheet. And it's right outside, kind of underneath where the stairs are by the blue room. Do you know where the time clock is? So if you're facing the time clock, it's to your left. And there's 2 yellow binders. So everything that we have in the shop is going to be in there with a couple exceptions. If you can go to the store and buy it, it probably doesn't have a safety data sheet. We're not legally required to have that. but any of the process chemistries, the stuff that goes into the plating lines, that will have a safety data sheet. So as I said, each chemical used at Cooperative has an SDS. They're written by the chemical manufacturer. They are here for you to use, right? It's very important that you know that they're there for you. So as I said, they're on the network and they're in those two binders. Nice thing is they are also that GHS, that globally harmonized system, is used on safety data sheets. There's 16 elements. We're going to go through them somewhat quickly, but I'll highlight the ones that I think of those elements that are most important for you. So number one, identification includes a product identifier. Again, like the label, this is potentially a trade name, not a chemical name. So I don't find number one always that helpful. The next three you see are in red. That's because those I think are the most important for employees to take a look at. So 2 is the hazard identification. Why is this hazardous? What are the hazards associated with it? This is going to have all the labeling information plus those pictograms that we saw on the label are going to be in section 2 of an SDS. So again, you find yourself in Spain and you don't, well, maybe you guys know the language, but I don't. I can't read it, but at least that pictogram is there and I can see what it says. I can see what the hazards are. Number 3 is important. This is the composition. So in this section, it should tell you what the hazardous ingredients are, right? Some of the chemicals that we purchase are more than one chemical. They're a mixture of several. This should tell you the things that the actual hazardous ingredients, with the exception of where it says trade secrets. There are provisions that if it's under a certain level, they can call it a trade secret and not tell you what it is. Now, they still have to tell you what the hazards are. Number 4 is perhaps the most important section of an SDS for those of you who may come into contact with some of these hazardous chemicals. Number 4 is first aid measures. What do I do right now if I've been exposed, or more importantly, if the person next to me is exposed, right? Because someone who is in an accident may not be able to take care of themselves. So how do I help the guy next to me that's having a problem, that's been exposed? So it will tell you there, get them to fresh air, flush the skin, that sort of thing. 5, firefighting measures. 6, accidental release measures, obviously important for management. 7, handling and storage. Do we have to put these in special storage conditions at certain temperatures, that sort of thing? Again, more important for those of us in management to make sure that we're taking care of them. Number 8 is critical for those of us in management. This is exposure controls and personal protection. So this tells us what are safe levels. So if our employees are exposed at this level, they're safe, but above that, we need to get some kind of either environmental controls or personal protective equipment to keep our employees safe. 9, physical and chemical properties. Is it a liquid? Is it a solid? At what temperature does it boil? At what temperature does it melt? That sort of thing. 10, stability and reactivity. 11, toxicological information, including routes of exposure. Number 11 is important for a doctor. So if you were to get exposed, or again, the person next to you gets exposed, it's very important that the doctor gets that information. So one thing that I try to tell everybody every time we have this training is, if you're going to the hospital for an exposure or you're helping someone else, more likely, go to the hospital. If you can, grab this. Take it right out of that yellow binder, grab that SDS, and have that with them when they get to the hospital so that that doctor has this information. And then it's a lot of other regulatory information in 12 through 16 that's probably less relevant to most of our employees, but It's there. Ecological information, how to dispose of it, how to transport it safely, any other regulatory concerns, and some other miscellaneous information. Those are SDSs. Take a look at them, know them, understand them, okay? So, how do we protect ourselves from chemical hazards? Probably the most important, right? So in this section, we're going to talk a little bit about routes of exposure, types of exposure, then we're going to talk about personal protective equipment, and then a little bit about eye washes and safety showers. So routes of exposure. If you get exposed to a chemical hazard, how does it get into your body? So the three most common ways with the chemicals that we have here: absorption, so you get it on your skin and it absorbs through the skin, maybe through the eyes, that sort of thing. Inhalation, it's a gas and you breathe it in. Ingestion, you eat it. All right, no, I get it. I'm not going to go out there and eat these things, right? I know that they're nasty. I'm not stupid. However, you would be surprised at how many people go about their job every day touching parts that just came out of a chemical bath. Maybe they rinse their hands, but they never take soap and water and really clean up their hands, and then they go and they eat a hamburger for lunch. Ingestion is more frequent than you might think. So, if you get nothing else from my training, learn this: wash your hands. Types of exposure. There's two types of exposure that you need to know about. We talked about this a little bit earlier, but there's an acute exposure. So this is caused by a brief overexposure, and you notice it right away. I got something on my hand, it burned. I breathed something in, I'm coughing, something's not right. That's an acute exposure. You know it, it's bad, you feel it right away. Chronic exposure, back to my eating the hamburger after working with chemicals all day example. Chronic exposure is something you don't notice immediately. But over longer periods of time, it becomes something more serious. You know, largely what we're worried about there are things like cancer. So what we want you to do is protect yourself from both exposures. Sometimes those acute exposures, most of the time acute exposures, people know, hey, I got to be careful, this thing's going to burn me, but they're less concerned about the chronic exposures. Very important that we're aware of both and that we protect ourselves from both. So, safety glasses. Safety glasses are required anywhere in the shop. The one exception is if you're coming in the morning or going home at night and you stay within the yellow lines through the main plant, because we only have lockers and that sort of thing in the basement at the other far end, you can get away with it for that short period of time. Otherwise, safety glasses need to be on. Safety goggles. Safety goggles are required when dispensing chemicals, making chemical ads, that sort of thing. Anytime where there's a significant possibility of a splash. So if you're working over a tank and you're pouring something into it, you need to have safety goggles on. Gloves. Gloves are another very important thing at a place like Cooperative Plating where we use a lot of chemicals. You'll see a number of gloves that we have here. I'm going to go through the most common. These blue gloves pictured are nitrile gloves. They're really nice and chemical resistant. They're available from the lab. I believe they're also in the blue room for your use. They're pretty good at minor chemical exposures. They're not something, if you're working inside of a tank and really really working hard, they will tear very easily, very, very easily punctured. So really for light duty, but they are good for if you're just pushing a hoist or moving some parts in and out of a tank quick. These yellow gloves are vinyl gloves. They're not nearly as chemical resistant. These are something that if you're using commercial cleaning products, that sort of thing, is a good idea to wear these. but not for anything that exposes you to the industrial chemicals that we use out there. These green nitrile gloves are the best set of gloves that we have for most of the tasks we have. They're fairly puncture resistant. They're made out of nitrile just like the blue gloves are, but they have this fabric woven on the other side, so they really resist puncture very well. These are, I believe, only available in the lab. But please, if you're ever going to be in the tank doing anything, this is the way to go. There's a few other types of gloves for specific tasks. For the people that work in masking, there are some silver gloves that are used for organic solvents, and we have some gauntlet gloves that go all the way up to your elbow. So if you're really working in a chemical, liquid chemicals, you really protects your entire arm. So there are some other options, but this demonstrated the three most common. Now this glove, you'll see in the shop a lot. This is a cotton glove. This glove is great for keeping fingerprints off of parts, and it's great for keeping oil off your hands if you don't want to wash your hands to get oil off for oily parts. However, it offers no protection for chemicals. It's a cloth glove, it's woven, so there's holes all over it. Anything can just seep through those gloves. So just keep that in mind. Cotton gloves are not for any protection. So types of PPE. We talked a lot about safety glasses. Again, wear them everywhere in the shop. Safety goggles when we're dispensing chemicals. We have a number of other things that are less common, generally used by our maintenance department. Those are things like Tyvek suits. So these are actually coveralls that cover from your neck down to your ankles. We have rubber boots, face shields, and then respirators. And just a quick thought on respirators. Unless you've been fit tested, nobody should ever ask you to wear a respirator. It is required by law to know that you are fit tested, capable of wearing a respirator, that you have to have a medical survey done. So, if you have asthma, high blood pressure, these sorts of things, they may make you go and see a doctor before you're allowed to wear one. So, unless you've been cleared to wear a respirator, nobody should ask you to wear one. And then hearing protection, which we'll come back to. Emergency eye wash and showers. So OSHA requires eye washes be provided to employees exposed to corrosive materials. Most of the chemicals we have in the shop are corrosive, so we have eye washes. Eye washes and showers must be no more than 10 seconds from hazards. In the shop, you can get from one end to the other in about 60 seconds or less. I have 5, I believe, sets of eye washes just down that middle aisle. The point of the 10 seconds is that's for a healthy, normal adult, right? When you have sulfuric acid in your eyes, it takes a lot longer to get somewhere. So keep that in mind. When you have a hazardous substance, you're going to have a hard time getting there. More importantly, understand that person that you're working with is going to have a hard time getting there. So please help them. Eye washes and showers are located strategically throughout the shop, and they're flushed weekly. So somebody from maintenance comes by and gets those eye washes so there's not rust and all that kind of stuff that's going to hit your eyes. Remember that eye washes and showers are for emergency use only. In my time here, I've seen people wash their hands in there, fill up their cups, water in there. I've seen them clean their dishes. That's not what they're for. Please don't use them for that. You're going to be very unhappy if somebody's in there rinsing their coffee mug out if you've got chemicals in your eyes. Keep the areas around eye washes and showers clear. There's always going to be some kind of markings in front of them. At the very least, keep things out of that way, but please, even more if you can. Same idea here, nothing within the marked area. So how to use eye washes. Begin flushing as soon as possible to prevent tissue damage. You're going to hold open your eyelids and you're going to roll your eyeballs to facilitate flushing. Again, you want to roll those eyeballs because you want every bit of that surface area covered with water, and you're going to flush for at least 15 minutes. So a couple quick thoughts here. This is exceedingly hard for some people to do on their own. When you have chemicals in your eyes, some people get almost hysterical. They have a really hard time. So once again, I ask you, please watch out for those people that you're working with. Help them where you can. If you have to, please walk them to the eye wash, because again, it's going to be hard to find. But if you have to, you put their head in that water, you hold their eyelids open, and keep them in there for 15 minutes. Now, when I say 15 minutes, you can give them a break every now and then. That's water hitting their eyes. But again, a break is 5-10 seconds out and then back in. Okay, I promised we'd come back to hearing protection. Hearing protection is important here at Co-op. The main source of noise that requires hearing protection is compressed air used to dry parts. You guys have all probably at this point seen people drying parts and heard the noise that comes from those air guns. Obviously, the health hazards going to potentially interfere with communication. It's going to cause some stress. You might not be able to hear alarms or equipment that sounds funny because it's malfunctioning. And obviously, the other health hazard is it can hurt your hearing over time. Exposure limit, OSHA says that you can be exposed to no more than 85 decibels on a daily average. So over an 8-hour period, no more than 85 decibels on average. How do you protect yourself? With earplugs or ear muffs. Everywhere where we've recorded more than that 85 decibels, you will see an orange sign that looks like that says warning, hearing protection required in this area. So the lab has gone through and actually checked with a device to tell the decibel meter to find out how loud it is. Importantly, every year, generally in late November, we have a company come out and test people's hearing. So the first year, it's sort of a baseline. Where are you at now? So that we can see if we're contributing to hearing loss. The types of hearing protection we have here at Co-op. I'm going to actually start over on the right. Those, the earplugs, those are in the safety cabinet. So if you don't know where the safety cabinet is, it is right across from the restrooms. And those are readily available anytime you want them. Please take them, use them. The lab offers the other two. So you've got a plug that's a reusable plug or ear muffs. The ear muffs, we keep those in the lab. They're a little more expensive, and we obviously want those to be used over and over. So we don't want everybody just taking new ones whenever they want. But we're happy to give them out. All right, now we'll get into the meat of it. We'll talk about the specific hazards here at Cooperative Plating. I mentioned corrosives earlier when we were talking about labels. Corrosives are chemicals that can burn your skin, that corrode metal. They are the most common class of chemicals we have at Cooperative Plating. You see some examples of corrosive chemicals here. Notice most of them have a DOT label on it. We didn't talk about that before, but that's a Department of Transportation label, that diamond shape, that says corrosive. All of our acids and strong bases are corrosives. So anything that says acid on the label, like the nitric acid or hydrochloric acid, you can assume is a corrosive. Anything that says caustic or has the OH in the name, or hydroxide of any sort, is a strong alkaline or a strong base, that's going to be a corrosive. So a corrosive is used to describe a liquid with a very high or very low pH. Generally, that's less than 2 or greater than 12.5 if you remember your chemistry. Where are you going to find them here? Like I said, just about everywhere. Solutions used for cleaning, stripping, and etching parts. So usually that's the first few tanks on a plating line. Oftentimes the plating chemistry itself is corrosive. The chromates that come after plating are often corrosive. Routes of exposure, most common with corrosives are going to be eye or skin contact, right? So absorption and inhalation. Some of the acids we have, hydrochloric, the most common, are also inhalation hazards. They tend to be gassing acids. Health hazards, serious burns to eyes and skin, and upper respiratory irritation. Talk a little bit about compatibility. Acids and bases should never be mixed. So corrosives themselves generally aren't as a class incompatible with other chemistries, but various corrosives can't be mixed together. So acids and bases, both corrosives, don't ever mix them. Remember your baking soda and vinegar volcanoes from your childhood? That's a acid and base reaction. We'll just say that the acids and bases we have here are much, much stronger, so it's closer to a real volcano. So organic solvents. Organic solvents are carbon-based chemical compounds used to dissolve other chemical compounds, usually liquids. So again, I know that doesn't, and they're often flammable. I know that definition isn't the greatest, but they're usually liquids. They have very distinct odors to them. They're used to dissolve things, oil in particular, and paint. So you'll commonly find them in paint and other paint products like paint thinners. MEK we use here in the masking room to dissolve paint. N-propyl bromide we use as a degreaser in our vapor degreaser in the back room. Routes of exposure, probably the worst is inhalation. Most of these are very volatile, meaning they go from liquid to gas phase very readily. So that's why you smell them so well. But they can cause some problems with skin contact. Generally, because they dissolve oil, when they get on your skin, they'll dry up and they'll take all the oil out of your skin and you'll be very dry and ashy looking. Health hazards and effects, so skin irritation like we talked about. Exposure to vapors may cause dizziness, nausea, and confusion. Chronic exposure can lead to central nervous system damage, kidney, brain, and liver damage. Maybe the most common use of solvents that are the one that most people know about are spray paints, right? Graffiti artists often got brain damage because they were sitting there spraying the wall and breathing on those fumes. Those were organic solvents that were causing those problems for them. From a compatibility standpoint, organic solvents, most of them are flammable. So again, we talked about oxidizers, making fires hotter and faster. Never mix a flammable with an oxidizer. So organic solvents should stay away from oxidizers. Cyanide compounds. So this description doesn't tell us much. Compounds include sodium cyanide, potassium cyanide, copper cyanide, potassium silver cyanide. Cyanide is a specific kind of chemical. It's a carbon with a nitrogen and a triple bond, if you want to really know what it is. Routes of exposure include inhalation, which is the most dangerous, but it can also be absorbed, it can also be ingested. Cyanide is very important to plating operations. It's the salt that really makes everything happen in a lot of our plating chemistries. The scariest thing about cyanide isn't those ones that say sodium or potassium or copper. It's hydrogen cyanide, which we don't have here. But you see in bright red there in the middle, contact with acids produces dangerous hydrogen cyanide gas. Hydrogen cyanide is what you see in movies where people use cyanide in their little capsules to kill themselves if they get caught as spies, that sort of thing. Hydrogen cyanide interferes with the oxygen metabolism process, making respiration difficult or impossible. So hydrogen cyanide absorbs into your blood at something like 1,000 times faster than oxygen. So with a very small amount in the air, it can kill you. Obviously use proper PPE. You're more likely to get exposed through absorption here because, again, we're not using the hydrogen cyanide. But back to the bright red and the hydrogen cyanide, that's only going to happen here if somebody does something wrong, if they mix things that shouldn't be mixed. So, my rule, don't mix anything. If you don't know what you're doing, don't do it. Don't mix things here. Cyanide compounds are hazardous materials and must be handled with extreme caution. Always wear the proper PPE when handling and dispose of waste properly. So sources at Cooperative Plating, we sort of listed them in the description: sodium cyanide, potassium cyanide, silver cyanide, copper cyanide. The zinc plating tanks, most of them are cyanide-based tanks. The copper plating tank on the nickel line and on the Ian Hand line, both cadmium tanks, and the silver plating tank all contain cyanide. Cadmium. There is an OSHA standard that covers occupational exposure to cadmium and cadmium compounds. It's 1910.1027. A copy is available to affected employees if requested. So why did I read that exactly to you? Because OSHA says that cadmium is a special hazard and something that they wanted to make a publication for specifically. So that 1910.1027 is a little, I believe it's about a 2 to 3 page information sheet about cadmium. Why do they care? What's cadmium? It's a metal, a soft bluish white transition metal in particular, but most importantly, it's highly toxic and carcinogenic. So if you're exposed to too much cadmium, it can cause cancer. It's used for corrosion-resistant plating, generally on steel and aluminum. It's really good for that, but it does cause cancer, so it's being used less and less. Here at Cooperative Plating, we have two cadmium tanks, and unfortunately the government still loves it. The military in particular still loves it because they have drawings from back in the 60s that still call it out, and they're still making those parts. There's been a big push to move away from it, but not yet. Exposure limit is 5 micrograms per cubic meter. Testing is required and has been performed on employees exposed to cadmium. So that 5 micrograms per cubic meter, to give you an example, think of a grape. A single grape is about a gram. A microgram is a 1/1,000,000th of a gram. So you cut that into 1,000,000 pieces. Did I do that right? Yeah. And so there could be 5 of those pieces in a cubic foot, a 3 foot by 3 foot by 3 foot section of air. So it can't be very much. The good news is cadmium doesn't get in the air very readily. So we've actually tested twice now at Co-op, and we were well below the 5 micrograms. We were in fact in undetectable limits of cadmium in the air. Routes of exposure, all 3 of them: inhalation, ingestion, and skin contact. Cadmium is in the cadmium plating tanks. There's also cadmium anode balls that are generally in the chemical storage area. Health hazards from improper handling: acute symptoms, respiratory irritation, fever, chills, metallic taste and or cough. Cadmium is more dangerous by inhalation than ingestion. So if you breathe it in, it's far worse for you. But again, remember, it's very unlikely that you're going to breathe it in. Chronic symptoms: increased risk of lung and prostate cancer and potential kidney damage. So protecting yourself from cadmium, obviously use proper PPE. Safety glasses, goggles, and gloves. Good hygiene, washing hands, no food or drink in areas where cadmium could be present. Don't eat or drink in the cadmium lines. Don't eat in the shop. It's just always a bad idea. Engineering controls and safe work practices. So if you're a plater and you need to turn parts in the middle of plating when you're on a cadmium plater, make sure you rinse in the dead rinse and then at least one more flowing rinse before you turn the parts, and use gloves to turn the parts. Use care when blowing out dead holes, right? So if there's a hole that doesn't go all the way through and you put an air gun on there, what's going to happen is it's going to come back towards you. So stand to the side of parts that you're blowing off. Any questions about cadmium? Okay, hexavalent chromium. There is an OSHA standard that covers occupational exposure to hexavalent chromium compounds. It's 1910.1026. A copy is available to affected employees upon request. So once again, OSHA says that hexavalent chromium is such a nasty compound that we're going to have a special publication for people to read. So if you ever want to read that, you come see me, or you find Lucas in the lab and we can provide you a copy. Again, why are they worried about it? What is chromium, hexavalent chromium? That description, unless you've taken chemistry, is probably not of much value to you. Understand that chromium is a metal, and there are different amounts of electrons that can be on a chromium atom. When there's a certain amount, it is called a valence of +6. That is the kind that we're worried about. That kind can cause cancer. So again, like cadmium, it's a metal that causes cancer. So what are our health hazards? Cancer, you've got an increased risk of lung, nasal, and sinus cancer. Eye irritation, it can certainly cause permanent eye damage. Skin sensitization, dermatitis, skin ulcers, allergic reactions. Sources at Cooperative Plating. We have a lot of hexavalent chromium sources. 4-dip 2500, which is the yellow chromate on both zinc and cad. Chromium trioxide, which is our strip for copper. The clear chromate on cad lines. Passivate line and the anodized line both use sodium dichromate in a couple tanks. There's a deoxidizer with chromate. Permissible exposure, just like cad, 5 micrograms per cubic meter. So a very, very small amount that you can breathe in. And like cad, we tested it and we were at essentially undetectable limits. There's actually, with hexavalent chrome, there's the 5 micrograms that you can't be exposed to, and there's also a 2.5 threshold limit. At 2.5 micrograms, we would have to do medical surveillance, meaning that we would have to send people who are potentially exposed at that level to the clinic every year, where they would get blood work done to test how much chrome is in their blood. Because we were below that, we don't have to do that. Make sure you use proper PPE when working with hexavalent chromium. So, we're just about to the end here. So we're going to go through some tips for using chemicals safely. Wear gloves when there's a possibility you will come into contact with chemicals. Remember, green gloves are best, blue gloves are almost as good, but wear gloves. Wash your hands immediately after using chemicals. When you go home at night, before you leave here, wash your hands. Before you eat your lunch, before you go to break, wash your hands. Before you go to the bathroom, wash your hands. After you go to the bathroom, wash your hands too. Don't be gross. But wash them before you go to the bathroom. Do not eat in areas where chemicals are used. Again, unless you've washed your hands, unless that surface is clean, you don't want food to potentially come in contact with it. Know your hazards. Read your SDSs. Know what you're working with. Make sure all containers have legible labels. If you can't read a label, you don't know what's in there, you don't know what the hazards are. Put safety first in your actions.